Hi guys, Mr. Hill here with your maths for today. We're going to be carrying on adding fractions, and this time we're going to go through one. So where we've been adding our fractions together, they've stayed nice and neatly within one. We're going to go through one today. So to get us warmed up, get us started thinking about fractions for today, have a go at these questions. Look carefully at the part-whole models. One of them, there's a nice easy way of doing it. See if you can find it. Question 3, you're finding the missing numbers. So we're looking for equivalent fractions. So just remember the trick for finding your equivalent fractions. Pause the video here to complete these tasks. Okay, how did we get on? Now we'll look at number 1 first. I did say to look carefully at the numbers. There's a trick you can use here. I know that 2 halves added together leave me with 1 whole. So I can take that out of my calculation altogether. I don't need to do anything with them. I don't need to multiply them by 2 to make them into quarters. And I have a quarter left over. So I've added the 2 halves together to make my whole, and I've just added the quarter on at the end to give my whole of 1 quarter. Question 2, we've got 5/7, 4/21 or 21sts, and 3/7. The easy way to do this is to make the sevenths into a fraction over 21. So we're going to multiply them both by 3. So what we're actually adding together is 15/21, 4/21, and 9/21, which gives us 28/21. Now, we could leave it like this, but it's an improper fraction. Let's turn it into a mixed number fraction because we're going to be needing to do that today. So we've got 1 and 7/21. Now I could leave this like that, but there's another step we can do. We can make it look even neater. So I'm going to look at these numbers, and I remember that 7 and 21 are both in the 7 times table. So if I divide 7/21, if I divide both numbers by 7, I get 1/3. So I've got a nice, neat finish there. So 1 and 1/3 is the answer to question 2. Question 3, 1/5 equals something over 15, which equals 9 over something. So these are all equivalent fractions. They're all equal to each other. So to get from 5 to 15, I need to multiply by 3. So remembering whatever I do to the denominator, I need to do to the numerator. So 3 times 1 will give me 3. I have 3/15. The second part of this question, 1/5 equals 9 over something. Well, I've multiplied 9, or 1 rather, by 9. So I need to do the same to my denominator. So 9 times 5 gives me 45. So let's move forward. I'm going to add 2 fractions here. I've got 5/6 and 2/3. Now I can't do that straight away. I need to look at this and I need to get my fractions to have the same denominator. So I'm going to multiply 2/3 by 2, which will give me 4/6. Now I've got my bar model drawn out ready, so I can get started. I've got my 5/6 already colored in. Going to add on another 6th, and I'm just going to add another one on at the end and keep going. Hang on, I can't do that. I'm working in 6ths, not 7ths. So I'm going to need a new bar, and I'm going to need to bring the next one over into my new bar. So I've got 2, then 3, and then 4. So I've added those together. Now I've got 9/6 in total. So using our bar model, so when we were doing improper fractions to mixed number fractions before, we used our bar models to help us. So I've got 1 full bar here. I've got 1 whole, and I've got 3/6. Now, again, I can look at my numbers and I know that 3 is half of 6. So I can divide those together, the 2 numbers, by 3. So that becomes 1 and 1/2. We can do the same working with 3 fractions as well. We did that yesterday. So again, we need to get our equivalent fractions to help us. So we've got 7/8 there. We're going to make everything equal to 8. So I'm going to multiply 3/4 by 2 to give me my 6/8. 4/8, so 1/2 multiplied by 4, and the 7/8 can stay the same. So I'm going to start my bar model off with 7/8. So I've done the first part. Then I need to start adding on the next one. So 1, now remembering I filled the bar, so I need to start a new one. And I'm going to add the other 5. So that's my 6/8. I've still got 4/8 to add on. So I've got 3, that's another bar filled. So I need the final one there. So in total, I've got 17/8. Of course, with this being an improper fraction, we're not going to leave it like that. We're going to turn it into a proper fraction. So I can look at the number of bars that I've filled, which there are 2 of those, and I have 1/8 left over in the final bar. So I've got 2 whole bars and 1/8 of a bar. So your turn now. Have a think about this one, and then have a think about the second question as well. Pause here to have a go at both of these. Okay, how did we get on with these? So obviously we can't add 11/18 and 5/9 easily. So we need to make 5/9 into an equivalent fraction. So to do that, I'm going to multiply the numerator and the denominator by 2. So I've got 10/18. I can now add these together using my bar model. So I've got my 11 there, adding the next ones in. I need a new bar because I've filled that bar up. I'm going to add in the rest as well. So that gives me in total 21/18. I'm not going to leave it like that. You know why. I like things to be neat and sorted out. So I'm going to look at my bars. I've got 1 whole bar and I've got 3/18 left over. So I've got 1 and 3/18. Now, can I divide these down and make them neater again? So let's have a look. Which times table can both of these go into? Well, they both fit into the 3 times table. So I can divide both numbers by 3. And that becomes 1 and 1/6. Now we'll have a look at our second question. I've not given you a bar model here. That was for you to see whether you wanted to carry on using the bar model or whether you were able to take the next step and can have a go at doing these without using the bar model to support you. So depending on how comfortable you are with improper fractions and mixed number fractions, if you're happier using the bar model, please continue to use it. Just make sure you have the right number of bars. If you're happy doing it with the arithmetic method, then carry on doing it. So we've got 11/12, 10/24, and 5/6 to add together. So I'm going to make everything equal to 12 because I've got 2 even numbers in 10/24. I can divide it by 2 and get my denominator to 12. So I've now got 11/12 plus 5/12. I've multiplied 5/6 by 2 to give me 10/12. So everything now has got the denominator of 12ths. So I need to add 11 and 5 and 10, which gives me 26/12. Now, this is an improper fraction again. My numerator is bigger than my denominator. So I can divide my denominator into my numerator, and that will go in twice with a remainder of 2. So just to show you a nice, easy way of solving this, we can use the bus stop method that we learned when we were doing division earlier in the year. So I can divide 12 into 26. And I know it goes in twice, and I have a remainder of 2. So just to show you the numbers come from, so the 2 is my number of holes. Hang on, my pen's just disappeared on me. There it is. And my remainder is my fraction that goes above my denominator. Just a little reminder there to help us out. So if we are dividing denominators into numerators, make sure the answer you've got on top of the bus stop goes as your whole, and whatever your remainder is goes over the top of your denominator. Now again, I can tidy this up a little bit. 2 and 12 are both divisible by 2. So I can make that into 1/6. So what we're always trying to do now, we're looking for the simplest form. We're looking for the first equivalent of that fraction. So 1/6 is equivalent to 2/12. 3/18, and so on as you go through the 6 times table. Okay, it's over to you now. Use the bar models for question 1. Make sure you're happy with those. If you need to use the bar models for question 2, please carry on. As I said, work with what works for you. Don't try and do it in a way that you find is a struggle. If you found a method that works really nicely and gets you the right answer, then carry on using that. Both question 1 and question 2, you need to find the lowest equivalent fraction as well. So you have an improper fraction to begin with, and then you need to make it into the neatest fraction you can. Question 3, you're going to match the correct answers. So you're going to match the boxes. You're going to need to work out what each box equals and match the boxes together. Pause the video here to complete your work. How did we get on with those? Just remember, if you feel like you've struggled with some of these, take a moment, go back, re-watch the video from up to this point, and then have another go. It's all about practice and becoming comfortable with how we're doing this. We'll move on for our answers now. So using our bar models, what I've done here, where I've got different numbers of fractions, I've used different colors. So A, I'm adding 2 fractions together. I've used blue and red to show those. B, I've used blue, red, and green, and the same again for C. So have a look at your answers. If you've got the improper fractions, well done. Give yourself a tick for that. If you've got them down to their simplest form as well, which was the second box you were asked to work out, even better. You can have an extra mark for that as well. Well done. So moving on, looking at question 2 now, completing the additions. We're adding together the fractions, so we need to do finding our equivalents, working out how many we've gone through to get from each one. So check your answers here and then press play when you're ready to carry on. Okay, so moving on, question 3, here are your answers. So we've got 3/5 and 9/20 is equivalent to 12/20 plus 9/20. Follow the lines, check your answers here. Okay, we're going to move on now. So we've got our word question now, we've got our reasoning question to have a look at. So Eva has bottles of lemonade, water, and apple juice. The bottles have a mass of 3 kilograms altogether. The bottles of water have a mass of 7/8 of a kilogram in total. Each bottle of lemonade has a mass of 11/16 of a kilogram, and Eva has 2 bottles of lemonade. How much do all the bottles of apple juice weigh? Take a moment, have a go at this, and then we'll go through how to solve this together. Okay, let's have a work through the working out together. So we have lemonade, water, and apple juice. We know the total mass of all the bottles together is 3 kilograms. So I have lemonade, I have water, I have apple juice. And I know my total is going to be 3 kilograms. Bottles of water have a mass of 7/8 of a kilogram in total. So I'm going to make a note of that here. Each bottle of lemonade has a mass of 11/16 of a kilogram. We have 2 bottles of lemonade. So I have 1 and 2 bottles of lemonade, both with the same mass. What I don't know is how much the apple juice weighs, so I have to work this out. So let's work with what we do already know. I'm going to change our water, 7/8. I'm going to make that into a fraction over 16. So I'm going to multiply that by 2, that becomes 14/16. Now I can start working through. So I've got to remember, I also need to work out how many 16ths are in the kilograms. So I've got 1 lot of 16/16, 2 lots of 16/16, and 3 lots to give me 48/16 in total. So I'm going to change my 3 kilograms for 48/16. Now I can start working out my answer. I need to add the known numbers that I've got. So I've got 11/16 plus 11/16 plus 14/16, which gives me 36/16. Now, I need to work out what the weight of the apple juice is. So I know my total weight, and I now know the weight that I've got already. So I need to do 48 take away 36, which will give me 12/16. I could leave this fraction like that, but you know me, we've been doing it all through this session. I'm going to simplify it. So she has 3 bottles of apple juice. So what's the mass of 1 bottle of apple juice? So I need to divide 12 by 3, which means I have 4/16 of a kilogram. So again, as I was saying, I like my fractions in their simplest form. So 4 and 16 are both in the 4 times table. So I can divide this fraction by 4, and I'm left with 1/4 of a kilogram as my answer. Well done if you've got it. If you think you need to go back over this again, take the time, rewind the video back and just go through it again. So I said there were some tricks to look out for. So when you're adding fractions together, now we've got 2 lots of 8s here and 1 lot of 7s. We've got 5 8s plus 2 7s plus 3 8s equals. Now I could take a lot of time finding an equivalent denominator that they can all multiply into, or I can look at the 8s. 5 and 3 added together make 8 8s, which is the same as 1 whole. So 5 8s plus 3 8s plus 2 7s. So 5 8s and 3 8s, as I said, makes 1 whole. And then I've got 2 7ths that I don't now need to find an equivalent fraction to work with. Have a look at this one. You might need to find one equivalent here, and you should be able to work the rest of it out really simply. Pause here to have a go. How did we get on? Now, I'm sure you've noticed that multiplying something from 13 to get to 18 or 9 is going to be really difficult. What you can do, you can multiply 7 9ths by 2 to give you 14 18ths. And 4 and 14 make 18 together. So we have 1 whole and 3 13ths. Now, we have the same again here. We're going to look at this one. Something over 24 plus something over 12 plus something over 4 equals 29 over 24. So the first thing we're going to need to do is make all of our fractions over 24. There we go. So we've got 29. Where are we going to start with this? So I'm going to put 3 in here. That leaves me with 26 out of 24, or 26 24ths. So I can split these now. I need to remember I need numbers that are divisible by what I've multiplied the denominator by. So in this case, I've multiplied 12 by 2 to get to 24. So I'm going to use 14 because I can divide that by 2, and that will bring me back. That leaves me with 12. Now, 6 is what I've multiplied my 4 by to get to 24. So I need something that's in the 6 times table. In this case, I've got 12. So I need to do the inverse divide back up. So I've got 14 divided by 2 gives me 7. 12 divided by 3 to give me, 12 divided by 6 to give me 2. Okay, your turn now. Work your way through these. Pause the video to complete them. Okay, ready for some answers? Check your answers here. And then the answers for question 6. This was the skill we had with multiplying and working backwards and forwards and finding what we can do. So multiplying by 3 and 4 for the first one. So for 1/4, we'd multiply it by 3 to make it into 3/12, and finding those equivalent fractions again. Well done today. I look forward to seeing your work up on Tapestry. Stay safe, and we'll see you all again soon.